exponent. So, for example, if you have 3 to the second power times 3 to the fourth power, you are going to add the exponent. So this would be 3 to the second plus 4. This would be 3 to the sixth. The same is also true if it's 3 to the fourth power times 3 to the negative 2. You're technically going to add them together like this, and that would be 3 to the second power. Okay? So that's the product rule. The second thing is the power rule. So I see a lot of people making this mistake, so I'm going to go ahead and write like 2x, y, let's say 2x squared, and this is being raised to the third power. So one thing is that for the power rule, you have to expand this. You're going to expand this 3 times, right? So technically you would have 2x squared y times 2x squared y times 2x squared y, right? So how many 2's would you have? You would have 3 2's, so you would have 2 to the third power. You would have 6 total x's, or x to the sixth power, and you would have y to the third power, right? This is equivalent, it's the same thing. So what you get is that when you raise something to a power, you have to multiply the exponents, right? You're multiplying the exponents, right? Okay, so that's the second rule. The third rule is the quotient rule. So just like the product rule, it is very similar. The only difference is that instead of adding, you're going to subtract. So if you have something like this, where it is 3 to the fourth power times, or 3 to the fourth power divided by 3 to the fifth, this is going to equal 3 to the fourth minus 5, and this would equal 3 to the negative 1 power, right? So you're going to subtract whenever you're dividing. Something to note is that if, let's just say we have something like 1 to the fourth negative 2, just as a reminder that if it's a negative on the bottom, this is technically saying 4 to the negative 2 power, which is the same as saying 4 squared, right? So if you have a negative exponent on the bottom, it's technically a positive exponent, right? Because it's a negative exponent, okay? Something to keep in mind. Okay, so the quotient rule is that if it is on the bottom, if you're dividing by the number with the same base, you're going to subtract the exponent, okay? Okay, we have power of a product. I think this is the rule that a lot of people are messing up. Power of a product. So when you raise, let's say you're raising 2 to the third power, you have x, and then you have y to the fourth power being raised to the third power. You're going to distribute this 3 to each one of their exponents, and you're going to multiply each one. So this would be 2 to the third times 3. This would be x to the first times 3. This would be y to the fourth times 3. So you would get 2 to the ninth power, x to the third power, and y to the 12th power. Okay, so if it's in parentheses, you're going to raise everything inside the parentheses, and you're going to multiply each one of the exponents. Okay? Okay, so that's power of a product. Lastly, we have power of a quotient, which is very similar to power of a product. It's pretty much the same thing. Power of a quotient. So power of a quotient is that if you have two numbers being divided by each other and they're being raised to another power, you're going to actually distribute the exponent to each one of those things. Oh yes. So as an example, that if you are going to raise a fraction to a power, you're going to distribute the power to each one. So it's going to be 3 to the fifth power, it's going to be 4 to the fifth power, and x to the 2 times 5, or 3 to the fifth power, 4 to the fifth power, and x to the 10th power. Okay. So again, whenever you have parentheses and you have an exponent on the outside, you're going to multiply the exponent of everything that's inside the parentheses, okay? So again, you're going to multiply the exponent of everything inside the parentheses. Okay, one last rule that I want to review, which I also got a lot of questions on, was, is everyone good with this? Can I take this off?
No.
Okay. Okay, so one last question here is, or one last thing I want to review, is that if you are, let's say you have x squared y to the third divided by 1 over x to the fourth y to the third, or let's say negative 3, let's make it more confusing. If you're dividing by something, you could always multiply by the reciprocal. What I mean by reciprocal is you just take the numbers and you flip them. So you could say that this is the same as x squared y to the third times x to the fourth y to the negative 3. Right? It's the same because it's technically this over 1. When you divide by something, you can always multiply by the reciprocal. Okay, so I'm going to say it again. When you divide by something, you can always multiply by the reciprocal. Is that if it's a fraction, you just flip it, right? You just flip it. You can always do that. For me, that's a lot easier. Instead of dividing, you can go ahead and multiply by the reciprocal. So in this case, it would be x to the 2 plus 4, y to the third minus 3. You would get x to the 6, y to the 0. Well, anything to the 0 power is equal to 1. So it's just x to the 6 power, and that would be your answer. Okay. Any questions at all? Any questions at all? Okay, if you had questions about the homework, I want you to try your best. Tomorrow, the first 10 minutes, we'll go ahead and review any homework problems that you want to see reviewed from any of the last 2 days. So if you have any homework problems you want to see reviewed, let's say you still didn't get it or you want to go over it, please find it